Okay, 7.3, number of solutions for systems of linear equations. Okay, so this section we're just going to look at cases when if you have two lines, or it could be more, but we're just going to look at cases two lines in this section. Is there when would there only be one solution? When would there be an infinity a number of solutions? And when would there be no solutions? Okay, and this is going to go back to the parallel. And this looks like perpendicular. It could be perpendicular, but it doesn't have to be perpendicular as long as they're crossing, so it doesn't need to be 90 degrees. Or cases when they're infinity number of solutions. So let's take a look. So intersecting lines, the first case. So remember when you're graphing the two lines in an equation, the solution of that the system of linear equations would be the point that they intersect. Okay, and you can see here when they're crossing one another or when they have a different slope, right? Where's my little highlighter here? Whoa. So when they have a different slope, that means they're going to have only one solution, right? The y-intercept could be anything, right? So that's because even if they have the same y, that just means they're going to cross at that y-intercept, right? If they don't have the same y, they have a different y, they're going to cross somewhere else because they have a different slope. Okay, so one solution. When would there be no solution? So you can kind of see right here. If the lines are parallel, and remember from the last chapter, parallel lines have the same slope, right? So as long as they have the same slope and different y-intercept, that means that they're going to have no solution. They'll never cross. Okay. And then finally, when lines have infinite solutions, or when they coincident lines, that means they are pretty much the same, or they are the same line, right? They have the same slope, and they have the same y, meaning they're just overlapping. So they're basically, that just means like, where are they touching the lines? Here they touch for one solution, only one spot. Here, no solutions, they never touch. Here they're touching everywhere, right? Because they're on overlapping. So that's the case where you get infinite number of solutions. So, or coincident lines, we call it. So let's look at different questions based off of this. And that's really all the new idea in the work for section 7.3. Okay, so you may get questions like this. I think the solutions is actually, if we scroll down a bit, so we'll take a look here. Okay, and maybe I'll also, I know it's right here, maybe I'll try covering it a bit. So, okay, there we go. And let's pull this down a bit. Okay, pretend like you didn't see the answer. Okay. Okay, predict the number of solutions for each system of linear equations and justify your answer. So we'll predict, and we'll look at it, and we'll see why. Okay, so you got your two equations here in your system of linear equations, y equals 5x minus 1, and y equals negative 2x minus 1. So basically our options are, does these two set of equations have one solution? Does it have infinite number of solutions, or does it have no solutions? So again, if you go up here, let's scroll up a bit. When there's no solutions, lines are parallel in different y's. One solution, they have the same, or they have different slopes, but the y just could be anything. And the infinite solutions is when they overlap, so they have the same slope and same y. So when we're looking at this question, okay, what's the slope? Okay, slope here is 5, slope here is negative 2. So slopes are different. The y is the same. Okay, when the slopes are different, that's all that you really need to know. So she kind of lost this white this box covering it. So anyways, the slopes are different. So you know that it's going to be this option, which has one solution, right? They cross one. So this will be one solution. Okay. What about here? And I'll pull this down in a second. Slopes are the same, and the y is the same. And you just look at the equations. They're exactly the same equation. So they're going to be overlapping. It should be infinity number of solutions. And the case here, same slope, but different y. Same slope, but different y. That means they have to be parallel. So this should be no solutions. So let's take a look. And there we go. No solutions, same slope, and it's pretty much what I said, right? So hopefully that kind of makes sense. We're just using that, looking at the m and the b values, the slope and y-intercepts. Let's scroll down a bit, and hopefully this kind of stays covered. If not, then I might just get rid of it. Yeah. Oh, it's this way now. I guess we don't really need this anymore. Okay. Oh, actually we do. This is just the algebra. Okay. How many solutions does each linear system have? Justify your answers. Okay. So in this case, we're doing the same thing as the right above, but in this case, they're not in the form y equals mx plus b. So first thing you want to do is just do the basic algebra that you've been doing the last few chapters. Move everything to one side and keep y isolated. So we can have it in the form y equals mx plus b. Same thing for the other equation. We're doing this because now we can compare the slopes and compare the y-intercept. So in this case, they have different slopes, but they have different y's as well. When you have different slopes, that just means it's going to be one solution, right? So one solution here. Okay. What about in this case? Okay. So first thing you do is set it up so it's like y equals mx plus b. Right? You're gonna have to move the x over, negative x, and divide by -5 to get rid of the 5 off the y, and eventually you get the two equations here. Okay. So by these two equations, you can see that they have same slope but different y. So the same slope, different y. That means it must be parallel, so there should be no solutions, right? Because they'll never touch. And last one here, once you do a little bit of algebra, and in this case, they didn't even put it into the form y equals mx plus b. I wonder if I could close these boxes. Okay, we'll just leave them open. So what they did is here, what do you notice about these two equations? The top equation is just the bottom equation, but divided by 2. So if you multiply by 2, then you can easily see that they're exactly the same equation. If they're the same equation, you're going to have infinite number of solutions, right? If you didn't see that, you could have changed it into the form y equals mx plus b, both of them, moved everything over, and you would have thought that is going to be the same equations then, and you would have came to the same solution as well. Okay, so let's look at the last, there's actually quite a bit more. Okay, so let's look at example 3, and I think I'll just leave it uncovered, and we'll just talk about how they get these answers. What does that mean? Okay, so let's read the question. In the system of linear equations, y equals 3x plus 4, and y equals 3x plus b, so we got our two equations, and this one they just left it as b, right? So we'll see what that is. So what values of b will result in a system that has, okay, so there are two equations, so, and they're saying it, the two equations has no solution, okay? So if they have no solution, that means that they're parallel, and they're obviously, and they're not touching. So parallel lines that are not going to touch have the same slope, so they have the same slope, and b, as long as it's not positive 4, right? So here they say this equal sign slash, it means does not equal to. As long as b is not equal to 4, it could be any other number, so it would have different y's, then that's going to be a case of parallel lines that are running next to each other and never going to touch. What about one solution? Okay, this is not possible. Why is it not possible? So let's look at, remember one solution, they need to have different slopes. Okay, we're already running into a barrier there. So in the equations, they say they have the same slope. So it doesn't matter what we put for b, they're always going to have the same slope. So it's not possible to have only one solution here. Okay. What about infinite number of solutions? So if it's infinite number of solutions, they're going to be the same equation. So y equals 3x plus 4, that means b has to be 4 to it to be the same equation, right? So, I tried to do my highlight thing, but it didn't work. Is this a highlight? Oh, it's right here. Okay. Yeah, b equals 4. Okay, so let's jump to example 4 now. In the system of linear equations, y equals negative 2x plus 1 and y equals mx plus 1. Oh, you can see the same sort of thing as a question we just did, but instead of b remaining as a variable, they give us what b is, but they leave slope as the variable m. So they're going to ask us questions about m. So what values of m will result in a system that has no solution? So again, if you scroll up, if you forgot, when does it have no solution? When the lines are parallel, right? So parallel lines means that they're going to have the same slope, right? But different y's. So here it's negative 2x, so that means m has to be negative 2, right, to have the same slope. But the y's are set the same. So if I put negative 2 here, it's going to be the same line. So there's no way for us to have that be possible. So that's why it's not possible. What about one solution? So if there's one solution, again, that just means that the slope is different. So as long as the slope is not negative 2 for this equation, anything else, so again, this equal sign slash means not equal to negative 2, then that will have one solution. Yeah. And finally, the case of infinite number of solutions. Infinite number of solutions means that they're the same line, right? They have the same slope and the same y-intercept. So -2. So m just has to be -2. There you go. That's kind of exactly what they wrote. Okay. Okay. Oh, there's not much left. So there's practice. We won't go over the practice because it's pretty much what we just talked about. You can do this for homework if you like, and just compare your answers to this. But you'll have homework in the textbook as well. Okay, let's just finish the last two examples actually. Okay, in the system of linear equations, y equals 4x minus 1. Can we just do this one? No. Okay. Oh yeah, because now it's... Anyways, we'll go back in. So in the system of linear equations, y equals 4x minus 1 and y equals mx plus b. In this case, they have m left at the variable and the b, the y-intercept, left as its variable form. So what values of m and b will result in a system that has... Okay, so it's the same sort of question, but now we're going to talk about m and b. So when there's no solution, again, no solution means that they're parallel and they have different y's. So parallel lines have the same slope, so m has to be 4, right? Oops. And then b could be anything except for -1, right? Because if it was -1, that means they'd be the same line, right? One solution just means that the slope is different. So m, as long as it's not 4. So that's why I said when m's not 4. And here, this sign again, if you don't remember, is epsilon, and r stands for all real numbers. So b could be anything. That just means b can be any number. It doesn't really matter. The important thing for one solution is that the m is a different slope than the equation that you're comparing it to in its system of linear equation. Yeah. And now we're looking at C. What would be the case of infinite number of solutions? So in the case of an infinite number of solutions, they're going to be the same line. So m has to be 4 and b has to be -1. That's what they got here, right? Because infinite number of solutions means that they're touching throughout the line at every point, and that's only possible if they're the exact same equation. Okay, almost done here. So in example 6. In example 6, there's a few ways you can do this question. One, the easiest way would be to just move everything to one side in the terms of solve it for y's in the slope intercept form, and then you can compare it pretty easily. Another way is to kind of see that this equation is pretty much the first equation multiplied by 3. Okay, as long as that works for C as well. So an infinite number of solutions. So if you basically an infinite number of solutions would be 3 times x, 3x, 3 times 2y, 6y, 3 times 4, 12. So if C is 12, these two equations would be exactly the same, and then that means they're touching on every single line here. Okay, that's one way to do it. I would stick to just changing it both to y equals mx plus b, then you can see the slope, and you can also see the y-intercept pretty easily. Okay? So try doing that. Should be easy to put into y equals mx plus b form. So this one, just quickly in my head, would be moving the x over. So it'd be y equals y equals 1/2, -1/2 x plus 2. So -1/2 x would be the slope, and 2 would be the y-intercept. And then you do the same thing here. You'd move over the 3x, -3x, and then 5 by 6 divided by 6. So this would also be -1/2 x for slope. So these two equations have the same slope. And then c would be the y-intercept. So 6 divided by c would be the y-intercept. Okay, and then one solution. One solution is not possible because, like I said in my head right now, when I just did the equations, these two equations have the same slope, so this is not possible. We went over C, and then for no solution, it means that if there's no solution, as long as they don't have the same y-intercept, so as long as C is not 12, these equations would be different, right? So again, if that didn't make sense, just put it in y equals mx plus b, y equals mx plus b, then it's pretty simple, right? C is just representing the y-intercept. Okay, again, more practice if you want. You can try this out and then see how you do compared to the answers. Otherwise, you can do the 7.2 and 7.3 homework for today. We're gonna just start chapter 8 on Monday, and just focus on chapter 7 today. And we just need to do chapter 8 next week. We need to do chapter 1, which is the finance unit, and then we need to talk a little bit about arithmetic sequences. And that's pretty much it for the course. So we just have pretty much two chapters and a bit. So 2.5 chapters maybe to go after this. Okay, all right, so I'll let you guys get to it. Let me know if you have any questions or concerns on Microsoft Teams.